Alright, so let's focus this video in on graphing. I see a lot of us kind of have problems with graphing. Let's take a look at number 28. It's in standard form. And what does it say up here on the instructions? It says first find the vertex. So let's find the vertex, and the vertex we're going to find by using x equals negative b over 2a. And of course, the only way to get that would be to plug in your b and a values. So let's do that. Notice that I use parentheses when I plug in. My negative 2 is going to go inside the parentheses, and my negative 1 goes at the bottom. So on top I really have a positive 2, and on the bottom I have a negative 2, which means that my x value of my vertex is negative 1. So I still need my y value. How do I find my y value? I need to plug it back into the original equation and find y. I want to zoom in a bit to do that. Once again, I am plugging in with parentheses, and I plug in my negative 1 values. And of course, you're going to do exponents first before the multiplication. A lot of people like changing plus plus. You can't do that because the exponent must be dealt with first, and negative 1 squared, that's actually positive 1, but then again you have the negative that comes down in front. Then we take a look at negative 2 times negative 1, that's a positive 2. And last but not least, we bring down the minus 1. And if we think about negative 1 plus 2 minus 1, the answer is 0. And that is our y value. Remember, we found x by using x equals negative b over 2a. We have x. Now we plugged it in into the x spots, and of course I used parentheses. I worked it out. I got 0, and that 0 value is my y value. So the vertex is really negative 1, 0. Let's go to negative 1, 0, and let's put a dot right there. There's negative 1, 0. Let me make it bigger. And let me draw my axis of symmetry right through that value. Okay. What do I do now? Well, give me a second. I want to graph it, but before I graph it, I need to understand that I either need more coordinates by using an XY table, or I could use the pattern if I know the pattern of A. And in this case, the A value is negative 1, so it's really easy because the A value of 1, whether it's positive or negative, has the pattern 1, 1, 2, 4, 3, 9. And I don't even think we're going to have the opportunity to use, to use 3, 9. But from the vertex, I'm going to go 1 over, 1 down, and that's going to be my new point right there. And then I'm going to go 2 over, 1, 2, and then go 1, 2, 3 down. That's going to be, actually no, I'm sorry, 4 down, not 3 down. Let me try that again. 1 over, 2 over, and then 1, 2, 3, 4 down. That's 2, 4. That's my new coordinate. And yeah, I'm not going to even go for the 3, 9 because that's already off the graph. What I am going to do is map them over to the other side. So map it over there. And the other one is 1, 2 units away from the axis of symmetry, 1, 2 units away this way, and that'll give me my other coordinate. So I need to draw this. Let me draw my parabola here. I want to go in red, the vertex to that, and then over here there. So there's my perfect parabola that's opening down with the a value of 1. Now let's go back to the instructions. It said find the vertex. We already did that. The vertex is 0 or negative 1, 0, and that is the answer right there for part A. How about part B? 4 other coordinates. Wow, we need 4 other coordinates. Well, obviously we had to graph it first. Now all we have to do is state the other coordinates. Well, there they are. 0, negative 1, 1, negative 4, negative 2, negative 1, and negative 3, negative 4. Those are 4 other coordinates. That would be the answer to part B. And what else do we need to answer? Let's see up in the instructions. It says to state the axis of symmetry. Well, we all know that the axis of symmetry is the line going right through the vertex. And the equation of the axis of symmetry is simply x equals the x value of your vertex, which happens to be negative 1. That's the axis of symmetry right there. Okay. What else are they asking for? Finally, they're asking for the zeros. If we take a look over here, it says D, the zeros for the following quadratics. Okay, so what are the zeros here? The zeros are the location where your graph crosses your x-axis, and as you can clearly see, it only touches the x-axis right there at the value of -1. So what are the zeros? The zeros are x equals -1. Yeah, it's the same thing as the axis of symmetry equation, or you could even give this 0 as a coordinate, the coordinate -1, 0. Okay? We might as well jump to this next one, number 29, which is also a quadratic. It's in a different form. It's in vertex form. Honestly, I like vertex form a lot better because you could instantly see the vertex. And that would be -3, +4. So let's go to -3, +4. That would be -1, 2, 3, and then 1, 2, 3, 4. That would be my vertex right there, -3, +4. Let's also draw an axis of symmetry right through it. Let me zoom in a little to draw the axis of symmetry. Here's the axis of symmetry right through that vertex value. What else do we need to do? We need to find more points. Okay, well, we need to graph this thing in order to find more points. Now, you could always go to the traditional XY table to find more coordinates. So you could plug in a number for X, work out the math, get a number for Y. But I'm not going to waste time doing that because I know that the A value has a pattern of, the A value of 1 has a pattern of 1, 1, 2, 4, 3, 9. But this A value is definitely not 1. It's actually -2. So I need to modify this A value of 1 to become the A value of 2. Who cares about the negative? Because all that means is that it's going to be opening down instead of up. But what I do need to modify are the outputs. In other words, the A equals 1 has to become an A equals 2. So that's going to become an A equals 2. And what about these Y values? I need to multiply them all by 2. So I'm still going to have a 1 for the X pattern, but the Y value is going to become a 2. The 2 is still going to be for the X, but the 4 becomes an 8 because 4 times 2 is 8. And the 3 is still a 3, but the 9 becomes a 18 because 9 times 2 is 18. Now we know that we're definitely not going to use the 3 and the 18 on this graph, but we could at least use the 1, 2, 2, 8 pattern. So let's go 1, 2, 2, 8 from this vertex going down. So we're going to go 1, 1, 2, and we're going to get that dot right there. And you could map it over to the other side immediately. So far you have those coordinates. Let's also go 2, 8. So from the vertex you go 1, 2, 1, 2, wait a minute, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. 8 right there. So let's put that dot right there, map it over to the other side. We clearly see that it's 2 units away, 1, 2, so go 1, 2 this way, and put your dot right there. And ladies and gentlemen, we have our parabola that's opening down. That's a little bit narrower because it's technically vertically stretched by 2. It is opening down because the A value is negative. Anyway, so we have the vertex. That was one thing they asked for. We have the coordinates. All you have to do is label them. And there they are, labeled. What else do we need? We already labeled 4 coordinates. We need the zeros. So the zeros are a little bit more interesting because we cannot see clearly where it crosses. So it's not at nice points. What we need to do is understand what zeros are. Zeros are X-intercepts. And how do you find an X-intercept? You must set Y equal to 0, and you need to solve. So what we're going to do is take the above equation and say that 0 equals -2 parentheses x plus 3 squared plus close parentheses squared plus 4. So we're going to subtract 4 first, subtract 4, and the 4's cancel. You're going to end up with a -4 equals -2 parentheses x plus 3 squared, and then you're going to divide both sides -2, and then you're going to have your new equation. 2 equals x plus 3 squared. We're going to square root to get rid of the square. Of course, when you apply a square root, you have to put a plus minus in front of your answer. After that, we have a new equation. Let me move this up a little. Our new equation is going to be x plus 3. There's no more square on it. Equals plus or minus the square root of 2. The square root of 2 you can't simplify, so what we're going to do is subtract 3 on both sides, and you're going to have your final answer. X equals the negative 3 plus or minus the square root of 2. And those are your X-intercept values. Okay, what does that actually mean? You could actually get the square root of 2 on a calculator, and you could add it to negative 3, and you could subtract it from negative 3, and it'll give you decimal values that are somewhere in the 4 point something range and the negative 1 point something range. That'll give you your exact zero values. So just because you can't see the zeros, the X-intercepts, just because you can't clearly see them on the graph doesn't mean that you can't find the exact values. These are the exact values right here, negative 3 plus square root of 2 and negative 3 minus square root of 2.